All right, today we are diving into the science of learning and memory. We're going to explore why we forget so much of what we learn, and maybe more importantly, how we can actually remember just about anything we want.
So let me ask you this. Have you ever spent hours studying for a test or maybe trying to learn a new skill, only to find that a couple days later that information is just vanished from your brain? Yeah, if that sounds familiar, you are definitely not alone.
In fact, it's incredibly common. Scientific studies show that we tend to forget about 75% of new material within just 48 hours. That is a massive amount of wasted effort, right? So, why does this happen?
Well, first things first. This is not a personal failing. It's not because you're bad at memorizing. It's actually just how our brains are wired to work. And, understanding this problem is really the first step to fixing it.
Okay, so let's meet the villain of our story, the forgetting curve. This was first described way back in 1885 by a psychologist named Hermann Ebbinghaus, and it basically shows this really dramatic drop-off in our memory. As soon as you learn something new, a clock starts ticking, and your brain immediately starts trying to get rid of that information.
So, how do we fight back against this forgetting curve? Well, the first weapon in our arsenal is something that honestly most of us associate with stress and grades, not with learning. But the science is crystal clear. One of the most powerful learning tools we have is the test itself.
Think about it. Most of us, our default study method is passive, right? Rereading notes, highlighting chapters, watching a video again. It feels productive, but it's actually super inefficient. The real magic happens with active recall, forcing your brain to pull information out from scratch. It feels way harder, and that's exactly why it works so well.
This whole phenomenon has a name. It's called the testing effect. And here's the crucial part. Every single time you pull a memory out of your brain, you're not just checking to see if it's there, you are literally strengthening the road, the neural pathway to that memory, making it so much more durable and easier to find next time.
And this graph shows it perfectly. It's from a 2003 study. So one group just kept studying the material over and over, while the other group was repeatedly tested on it. Now look on the left. After just 5 minutes, sure, the study group did a little better. But look what happens after 1 week. It's a complete reversal. The group that kept testing themselves remembered way more. So testing doesn't just measure what you know, it actively builds.
Okay, so we know that testing is super powerful. But that brings up the next big question, right? When should you test yourself to get the best results? Because just cramming a bunch of practice tests right after you learn something, well, that's not the answer.
It all comes back to this really simple idea. Our brains are incredibly efficient machines, so if you don't send a signal that a piece of information is important by, using it again, your brain just assumes it's junk trivia, like what you ate for breakfast 3 weeks ago, and it gets rid of it to make room for other stuff.
And that brings us to our second hero, the spacing effect. Turns out, Ebbinghaus discovered this too. The idea is simple but totally profound. We learn things so much better when we spread our reviews out over time. Seriously, one review session today and another in a few days is way better than 2 sessions back to back.
Just look at this chart to see how it works. This is from a classic study back in 1939. That dashed line at the bottom? That's the normal steep forgetting curve we talked about. But see those solid lines above it? Each one is a group of students who were tested at different times. Notice how every single time they took a test, that downward slope of forgetting just flattens out. It's like a strategically timed test hits a reset button on forgetting.
So what does this actually look like in practice? Well, the ideal schedule isn't random. It expands over time. You review the material pretty soon after you learn it, then you wait a little longer, then even longer. See? Each time you successfully remember it, you're basically telling your brain, hey, this is important for the long haul, and you can afford to wait longer before the next check.
So what we have here are 2 incredibly powerful science-backed principles. Active recall, which is what you should be doing, and spaced repetition, which is when you should do it. And when you combine these 2, you get a ridiculously efficient system for learning.
And this isn't some brand new idea. Back in the 70s, a guy named Sebastian Leitner came up with a clever system using flashcard boxes to do a basic version of spaced repetition. But today, we've got sophisticated software that can track thousands of different facts and calculate the perfect time to review every single one.
And you can use this for anything. The applications are endless because the system doesn't care what you're learning. Medical students use it for anatomy, people use it to learn new languages, lawyers for case law. You can even use it for stuff like geography, musical chords, or just getting better at remembering people's names and faces.
So when you make this shift, when you go from just passively rereading to this active, spaced-out approach, you're not just studying more effectively. You are fundamentally changing your entire relationship with learning and, well, with forgetting.
And the evidence for this is rock solid. We're not talking about some new fad. This has been building for over 100 years. From studies on school children back in 1917 to research on thousands of students in 1939, the data has always pointed in the same direction. Active recall and spacing things out builds better, long-term memory.
The people who created SuperMemo, one of the very first spaced repetition software programs, they had this slogan that just nails it. The whole idea isn't just to remember a bit more. It's to build a system where keeping things in your long-term memory becomes so reliable that you can basically forget about forgetting.
So, the final question is really for you. Think about that language or that skill or that complex subject you've always wanted to get a handle on. What could you really truly master if you stopped fighting against your brain's natural tendencies and actually started working with them?